at 0 is the prediction of the unlimited capacity parallel model. This is an unlimited capacity benchmark. You can see that all the empirical data actually lies underneath it. So now, I need to ask you to mentally change your mindset. On this figure, low is bad, high is good. Low is bad, high is good. So if this is the benchmark, if this is unlimited capacity, all the teams in all conditions exhibit some sort of capacity limitation. But the capacity limitation is not the same for the collaborative and competitive conditions. So again, let me point out the collaborative. So this line would be the collaborative condition, and this line is the competitive. So of course, as you would expect, the collaborative advantage is preserved when we move on to the capacity space. Better team performance when they are trying to collaborate, and this advantage is unique to human-human teams. It does not show up if you look at teams that are made of one human and one bot. Does that make sense to everybody?
So, excuse me, I know I'm going to keep interrupting, but it's extremely interesting. Is there a line that would correspond to something like a Grice bound or
Yes.
a fixed capacity or something?
Sorry. Somewhere around here. Yeah. So underneath, so somewhere around, I think about here, there would be a line that indicates the Grice bound. If you remember your Grice bound, this would be equivalent here to the performance of the single best individual. But it is below our figure. So maybe just to follow up on that, I should probably add, but we'll see this in a different form in just a moment. You know, if I were to really summarize quickly the results that we see here, first of all, the group is better than any individual. The individual data will be somewhere around it. The second interesting observation, all values are at CP smaller than 0. So all values are showing some limitation of capacity. So you take two agents, you put them together, and they no longer perform at the same rate or ability that they would have played if they were on their own. There is a collaborative advantage, so collaboration is better than competition, but this is true only for the human-human and not for the human bots. I'll now show you the same results, but I'll do a simple transformation on them to maybe, sorry, do you have a question?
Oh, I was just wondering, the previous slide, maybe you say that where is the separate human condition?
Yeah, so I just used interchangeably, I think, the terms separate and individual.
Right.
So,
Okay.
you know, Jim called it individual, and must separate it to be somewhere along here, and we represent it by the Grice bound is some lower limits. I normally need to have a huge spiel on why we use a model-based measure. I don't think I need to do it here, but I do want to offer a simple intuition to how we can interpret those results in a more humane way, one that does not require the capacity coefficient, but is easy to interpret. So let's think about this scenario. Let's suppose for a moment that player A alone can juggle the balls, right? They can keep two balls without hitting the floor. This is their level of performance. And let's also suppose that player B can keep three balls at some level of performance. So we let them play, and we see that when they're alone, they're able to keep three balls at, I don't know, maybe 60% correct. Let's suppose now that when they are playing as a team, they keep four balls together in the air. So let's look at those numbers for just a moment. First of all, we can see that at a team, they do not perform as well as we would have expected just by adding up their abilities. If we were to add up their abilities, we would say, hey, player A can keep 2, player B can keep 3, put them together, they should be able to hold 5 balls in the air. So this team is not showing unlimited capacity. They have impaired capacity. But you can also see that despite having impaired capacity, if I'm a manager, if I'm a team manager, it is still worth my while to have 2 players rather than 1, because together they give me 4 balls. 4 balls is more than I would have gotten from only having this player, or only from having the other player. So, in this example, the team performance is not as good as unlimited capacity, but is better than any single individual. We can now take our actual empirical data and represent it in a tantamount, in a similar manner. So this is how we do it. So over here at the bottom, this is load, right? So remember, 1 ball, 3 balls, 6 balls, and 9 balls, so the different levels of load. And each one of these lines represents either a single player, another single player. So these are the 2 individual players, or the competitive and collaborative conditions. What we do here is we agree on some arbitrary level of performance. So just some arbitrary cut-off point, and I say, let's say that the arbitrary cut-off point is a miss rate of 40% or hit rate of 60%. So I will look at what happens at the point whereby the players miss 40% of the balls. And once I do that, when I cut off the empirical data curve, I can derive the number of balls they can hold in the air. So, for example, each and every individual, if you do this, so this line goes all the way here. For the individual lines, this would be about 3.6 balls. This means that if you look across all individual, across all conditions, in the separate condition, you'd see that on average they can hold 3.6 balls at a level of performance of 40% misses or 60% misses. And then I continue this line until I hit the group. And when I hit the group, I again draw a perpendicular line to the bottom, and this gives me about 4.5 balls. Now, remember, we can use this simple calculation to evaluate what would be the performance based on unlimited capacity, and then tell how well our team is doing. So, if my 2 individual players are each performing at 3.6, and I add them up together, I will end up with 7.2. This is just a rounding, because this can be more than 7.6. But the actual group performance is around 4.5 balls. So again, this is just another way to reinforce, I suppose, the finding that we have observed earlier. When 2 players are put together, they do not perform as well in a team as you could have predicted based on summing their individual ability. And nevertheless, they perform together as a group better than what each and every one of them performs alone. So there is a slight advantage in actually putting people together to perform the job, but not as much as one could have expected if the capacity of the system is unlimited. So far, I've only talked about performance, how well players are performing the task. In the next 10 minutes or so?
15.
Oh, 15 minutes. So in the next 15 minutes or so, I will talk now not about performance, but rather about the behavior or the strategies that the players are using. And at the very end, I'll try to connect them and suggest or ask, is there a connection between performance and how players move together? This will be quite an interesting question after. So, team behavioral pattern. What do we do? I mentioned earlier that when the players are moving, we record the location of each of the players at any given moment. From this, we can calculate lots of interesting measures. really a lot of interesting measures. But the one that I would like to illustrate to you here is called momentary distance. And because I've promised you to use my hands, I feel obliged to do this again. So momentary distance is calculated in the following way. On each and every point in time, I calculate the distance between two players, and I say, so right now the two players are in this situation, that would be the difference between them. The next refresh of the screen, let's say that they are both moving to the same direction. The momentary distance had not changed. It stayed the same. Now let's say that one is staying and the other one is moving. Now the momentary distance increases. And now it increases, but now momentary distance decreases. Right? So momentary distance is a very dynamic measure because we calculate it over and over again in each and every time point. Does that make sense, the calculation? And these are just example histograms of momentary distance across conditions. I will combine it to a more sensible figure if Marek did this properly. So this is now just the average momentary distance score. So again, let me explain how to read this figure. This is workload, from low to medium to high to very high. And this is now screen proportion. So the screen proportion means that the higher you are, the further away two players are. And the lower you are, the closer they are to one. And we can see what happens when we are looking now not at the performance, but rather at how close people are with respect to one another. So the conditions that we see for the human, very broadly speaking, are separate or individual, depending on how you like to read. So individual and competitive are down here. Collaborative is up here. And you can see that this difference seems to be larger for the human than it is for the human boat. Sometimes for the human boat it is even non-existent. What does this mean? How we can interpret this? Well, just intuitively, you can make a guess right now. Later on we can test this, either empirically or in a model, but you can speculate. Perhaps in the human condition, when people are collaborating, they know that they don't need to be in the same point of space. They know that if they're working together, they can actually divide the screen or share the screen so that they share the labor. So a key concept here is the division of labor. Right? If you're working together with someone collaboratively, don't do their job. They do theirs, you do yours, and together you maximize the output. And this is the first evidence that we see for this kind of behavior. We run lots of other analyses, as I mentioned both Mary, but now later on, calculate very different measures, and a lot of those measures are actually taken either from biology or from sports sciences. So if you think about our little game, what our little game has is two players that are moving with respect to one another. If you think about biologists who are interested in the mutual motion of birds in space or schools of fish, they're interested in a very similar measures. So some of the next analyses that I will show you are actually taken from the study of birds' motion or school of fish in the water and how they move with respect to one another. And another measures are also adapted from sport sciences. So you can imagine that in sports sciences, if you're a coach of a soccer team, and this is to me a really interesting one, if you've ever watched a good professional soccer team, as soon as they take control of the ball, all the players are running to open up the field. They will take different positions in the field. If you've ever seen a group of kids playing soccer, as soon as the ball is here, everybody is running into the same spot. Very inefficient use of space. Right? So sports scientists are interested in measuring how the team is actually behaving in terms of their mutual motion. And the main finding that we come up with thus far is that, by and large, less correlation in motion, movement, is associated with improved team performance. Let me show you how a figure may look like. And again, we have many different measures of behavior. This will be one of them. So over here, this is our capacity coefficient. I should have written here our beloved capacity coefficient. So high is better. And over here, it is the proportion of highly correlated segment. Essentially, the further you move to here, the more correlated players are. So let me just give an example. If you're on this side of the figure, very high correlation. This could be something like this. That's high correlation of movement, right? By the way, highly correlated movement could also be something like that. That's also highly correlated. But for now, let's not worry about whether correlation is negative or positive, just the notion that it is highly correlated. If you are on this side, there's low correlation. Essentially, any player is doing whatever they want, right? They don't, I don't know, I can do this. My hands are connected to the same brain. I can't control myself. This would not work for me, but you can imagine that for the left case, the motion of the agents is uncorrelated. And what is most important, I think, to see here is that the regression line is going strongly down, meaning that no correlation, you have high capacity of the team, and as the motion gets more correlated, the performance of the team declines. Think about this for a moment, and Mario mentioned in his talk, I think, the inefficiency of correlation, right? You said something like, if there is correlation, you are just duplicating inefficiencies or something like that, right? So if you want to reap any gain from multiple players, you don't want them to do the same thing. And this is what our data is showing. I think I have 1 more minute. So, sorry? Oh, 5 minutes. Okay. All right, so let me just summarize what we have, and then we use the time for questions, I suppose. So we ask what happens to people's performance as behavior when they're operating within a group. I tend to think about these 2 questions as actually being related, so I would add now a 3rd question. What happens to performance as we let multiple agents work together? What happens to their behavior as we put multiple agents to work together? And what is the relationship between performance and behavior? As a quick summary of the results, we discovered that the performance and the capacity of the system is better in a collaborative than in a competitive environment. You know, drop science for just a moment. Don't think about science at all. I think there's some reassuring message to this in a very global sense, right? That somehow, you know, a collaborative effort could lead to better consequences, better outcome than collaboration. Do I take it now to the financial markets? No. This is tested in a very highly controlled environment. But nevertheless, I think there is some reassurance in that finding. Remember that overall team capacity was still limited, but although it was limited, it was better than any individual. And also that correlated behavior is associated with less efficient group performance. So if you want the team to perform well, you do not want your agents to do the same thing. You don't want them to mimic the motion or indeed the will of one another. In this study, we focused on a very small team or group of two individuals, either humans or a human and a bot. But I'm sure that you will appreciate, much like myself, that those kinds of questions could be equally and perhaps even more important if we expand them to the broader horizon of social psychology, perhaps. What happens in larger groups? Can we expand those methods to even larger groups? And with that, I'll stop. So, thank you very much. If you'd like to read a little bit more about this, I think this will be the seminal paper where we developed the platform, but there's also some follow-up work that looks at developing a measure of entropy. I think the last paper, I've not touched this at all, but since I had an extra couple of minutes, I mentioned very briefly something that I did not plan to talk about, and this is the notion of trust. There is a lot of work in computer science about trust in human-bot automation. I'm not talking about this right now, but I would only suggest that perhaps the question of trust is important to human-bot and to human-human collaboration equally, right? So perhaps some of the results that we see about willing to share the space or not comes from the notion of trust. So just to give you an example, and this is now a speculation, because we did not ask this the participants, right? So what I'm telling you now is only a speculation. But let's suppose for just a moment that a team is sharing the screen in an efficient way. They don't move together to the same space. This would be very inefficient, right? Rather, one player is here and the other player is here. To afford, to allow that division of labor, this player needs to trust that player to do the job on that area. If this player is not trusting that player, they will move here to cover up for them. So perhaps somewhere, in a very underlying and important way, the notion of trust is important to collaboration as well. Thank you very much, folks.
Very interesting talk. So just wonder, because you presented data by applicating with all the data points together. So I just wonder whether there's a practice effect, because maybe for the first collaborating, they will show limited capacity, but later they can show super capacity.
Yeah, I think it's an excellent question. I'll repeat it. To express good collaboration, do you need to learn with your teammate perhaps their behavioral patterns so that you can maximize performance? This we haven't looked into yet. There's a lot of data coming from this, so I would imagine one of my students would be tasked with this job. I haven't picked up yet who this would be. So, but someone right now in Newcastle, Australia does not know it yet, and they will have to do this analysis.
Thank you for a very wonderful talk. So, in previous, you have conclusion that more correlate behavior lead to less efficient group performance. But like immediately, I think of some other kind of sport like rowing or tug of war. In that kind of group task, seems to me that like the synchrony between players is very important. So I was wondering how do you respond to that?
It's a perfect point. What can I say? Yes. So some sports require the synchrony, and it's a good example that you've offered rowing, I think, because there's probably some summation of force or power there. When I thought about this question earlier on, I've never thought about rowing, I have to say. I was thinking about synchronized swimming. And the reason I was thinking about synchronized swimming is that in synchronized swimming, the swimmers do not do the same thing, but they still operate in synchrony. Maybe they operate in a symmetric way, you know, the way that Dr. Chen shown us would be ideal, right? So they are not doing the same thing, and nevertheless the hedonistic experience is, I suppose, enhanced. I don't have an answer to that yet, right? So I have not mapped the different sports or the different roles in ways that allows me to think, yeah, maybe this is for you, maybe this is something that you can in the future. Excellent question, thank you.
Yeah, it's very interesting. But I'm wondering if there might be like a more global model that really that spirit, you could have imagined people like at Cirque du Soleil or something, that they have a beautiful kind of symmetry and progression and gestalt of their performance, but each one is maximizing something that makes the overall global thing look better or look perfect. Right.
Yeah. That is an excellent question, and I have to admit that this line of effect is more led by my students than myself. I just maybe repeat it in a way that would pertain to the game. In this game, although players could hit different balls, at the end of the day they have done the same type of thing. You can think about other games whereby different players take different roles. There are different characters. One role could be the warrior, the other one could be the sorceress, and so on and so forth. And so the question in the more broad sense would then be, how do you build a model that accounts for a good behavior when the roles are not identical, but rather are very different? And I think this relates, if I may be permitted, to another question that concerns the division of labor, and also maybe part of the sponsoring agency's interest. So this project is supported by the Muri Initiative. It's an American initiative, and in this particular project we look at human-bot collaboration in cyber security. And here the question might be something like this. Would team performance be best if you let humans do what they are good at, and you let the bots do what they are good at? So there's this notion, at least intuitive notion, that people are very good in a big picture understanding that requires contextual cues, and the bot is very good in fast and iterative processes. So that is already going into the realm, I think, of Jim's question. No longer do they do the same thing. Now we assign different roles to them. And I think that in the long run, we would like to have our team composition closer to that. We would like to have a team that leverages the strength of each player or each, let's say, each agent within the team. Let the bots do what they are good at, let the humans do what they are good at, and let us benefit from the strength of each organ or component of this team.
One quick question, maybe final. You didn't talk about how they correspond to the Miller bound, and is there any kind of performance where you would expect that kind of level of supercapacity for the upper bound?
Could you remind me your name, please? I don't think you said what your name was.
Oh, my name is De Wei. De Wei.
De Wei?
Yes.
De Wei. So De Wei had presented us with a scenario whereby the motion of the agents or the actions of the agents are working exactly towards the same thing. So maybe if we just take his example, we can think about two rowers that are working together in a boat. But now, not only that they are working together in a boat, their combined action could also, through the rules of hydrodynamics, which I know nothing about, be transformed into a mutual benefit that is better than summing those individual effects. Or maybe it is really just the, just the presence of another athlete that makes you work harder. When you're fatigued and you see them continue to work their hardest, you continue to work hard despite your inclination to stop and rest. Right? So I do believe that in our nature, we're a competitive beast, a competitive machine, so to speak. And the presence of others, really, no, let me rephrase this. In some scenarios, the presence of a community around us brings the best out of us. Maybe to the extent that we overperform what we would do in other conditions. Maybe somehow in the presence of others, we perform better than what we would do otherwise. And social psychology had claimed this for a long, long time. These are the phenomena of social facilitation. So I would argue this. Social facilitation is nothing but a form of Gestalt.
One last question. So there's this famous paper